Science 10. So in this video, we're going to be looking at classifying chemical reactions and predicting the products. Here you can see 4 different ones. We're going to look at each of these really quick, but take note of some of the names that you see and just sort of take a look at these pictures. But yeah, let's begin. Let's start by looking at formation reactions. So just as part of an intro. So here we have a formation reaction, and you can see basically we've got 2 elements coming together to form one new compound. So here we've got some sulfur and oxygen combining. You can see the reaction right up here, so it's a fairly violent reaction, releasing a lot of heat and creating sulfur dioxide. Also notice how this reaction is balanced, but yes, this is a formation reaction. So 2 simple elements combine to form a compound. Here we have a decomposition reaction. So in a decomposition reaction, it's like the opposite of a formation reaction. So essentially what you've got happening here, you can see water, and we've got a picture of it happening. We can see how the water is being decomposed into hydrogen gas and into oxygen gas. I'm just trying to point at it. The screen really won't let me do it, but ultimately you can see what a decomposition reaction is. We're breaking down a compound into its elements, and this is exactly how to do it with water. Here we have a single replacement reaction. Now take a look carefully at what's happening. In the picture you can see we put some solid copper into silver nitrate, and see how the copper has replaced the silver. It's kicked the silver out, so it's a single replacement of copper replacing that silver. See now on this side we've got copper nitrate, and you can see the solid silver forming on top of the copper rod that's been put into the silver nitrate. Single replacement. Copper has replaced silver, literally kicked the silver out of solution. Here's a double replacement reaction. Look carefully at the equation, but what you're going to be able to see here is we've got the lead nitrate, and the lead is kicking out the sodium here and sodium iodide. Notice how we now have lead iodide, and you can see what lead iodide looks like. It precipitates, so we definitely see a color change. We see a precipitate form. We see a reaction happen. Again, the lead has replaced the sodium in sodium iodide, made lead iodide, and now of course we have sodium nitrate, and the sodium replaced the lead in the lead nitrate. Finally, we have a combustion reaction. So this is a hydrocarbon combustion reaction. We've got 1 mole up here of methane gas reacting with oxygen, and notice what the products are: CO2 and H2O. And all hydrocarbon combustion reactions, whether it's methane, propane, butane from a lighter, is going to be the same basic reaction, burning with oxygen, creating the products of CO2 and H2O. That's a quick intro to the reaction types. Let's talk a little bit more about each. Okay, so we've had an overview of those 5 major reaction types. Of course, we got the names for 4 of them right here, and yeah, let's just continue looking into these. Let me share my screen. I'll also show you where you need to be at right now. We've just started Unit 2, but it's well underway. Already you need to have done the chemical reaction and solubility assignment. You should also have completed the balancing chemical equation assignment. You can ideally have done this quiz before this video, but that's okay if you're watching this video and haven't done this quiz yet. Basically, what's next is this whole section on types of chemical reactions. So there's about 4 days in here, and really the purpose is to prepare us for this this lab. And so that's really your goal here, to get a really good handle, obviously, on balancing chemical equations. And so there's going to be lots of practice in this, but also recognizing the different types of chemical reactions. So that whole section, there's it's pages 10, and again, these page numbers might be slightly different because we're been building and adding to this reading resource. This is the reading resource you've got inside of Moodle, but you're basically working through pages 10 to 19 with all of these different types of chemical reactions, and there's also support videos to help you make sure you can balance them, and so you'll want to be working through all of those. Here's where we are in a textbook. So basically about page 93, but let's get underway and look at chemical reactions, how to identify them, and how to predict the products. That's really, really critical. And essentially, you're going to be given a word equation. You're going to be given some words. It's going to be perhaps as simple as methane burns. You could literally be given that. Well, that's a combustion reaction, the word burn, right? So, we'll get to that in this lesson. So yeah, our concepts today: classifying and identifying the 5 types of chemical reactions, predict the products of chemical reactions. So that's really, really critical. They're the 5 types: formation, decomposition, hydrocarbon combustion, single replacement, double replacement, and of course, writing balanced chemical equations is really critical. So yes, so let's begin. Let's start with a formation reaction. All right, and take these notes with me. Always pause the screen. Again, make sure you've got your periodic table, and we can see a couple formation reactions right here. We've got sulfur combining with oxygen to make sulfur dioxide, and this is hydrogen gas and hydrogen gas and oxygen gas combining an explosive reaction to create water. Believe it or not, that reaction releases a ton of energy and can literally launch the space shuttle. But in a formation reaction, you have simple elements making a compound. Here's an example. So let's write the word equation for this first together. So we've got, let's make my marker a little bit thicker so the writing looks semi-okay. So we've got sulfur. Sulfur combines. So again, write this down because you need to be able to read these words and then convert it into that. I know we've got the answer right there, but a good way to learn stuff is to kind of look ahead and see what the answer is, so your brain starts to get an idea of the pattern. But we're telling your brain, okay, you need to be able to read this and convert it into a chemical reaction. So sulfur combines with oxygen to produce sulfur dioxide. To produce a molecular compound. And let's try to spell dioxide correctly. There we go. Because sulfur is a nonmetal and oxygen is a nonmetal. So that's definitely a molecular compound. From your periodic table, when you see the word sulfur, you need to know it's S8. You should put that on your periodic table so that you just know that. That is how sulfur exists in its most stable form, with 8 sulfur atoms bonded together, a fairly large molecule. Combines with oxygen. You know how to write oxygen. Now, of course, we're already given the product, but you may just be given these 2 and have to predict. Okay, so sulfur combines with oxygen. What happens? Well, they're going to come together and they're going to form either sulfur dioxide or trioxide. A question like this, we will give you the answer. You don't have to somehow figure that out. So indeed, we're just going to need to write the formula for sulfur dioxide. This is very common in volcanoes, actually, and also the burning of diesel and different fuels that have high sulfur content. You're going to get sulfur dioxide. This is not balanced. We've got 8 sulfurs here and only 1 there. So let's balance the sulfur off. Okay, now I've got 8 sulfurs, but I've got 8 times 2. I've got 16 oxygens. So we're going to have to put an 8 there. Okay, 8 times 2, I got 16 oxygens. I got 16 oxygens there. I got 8 sulfurs, and I got 8 sulfurs there. There we go. It's properly balanced. 1 sulfur, 1 mole of sulfur combines with 8 moles of oxygen gas to make 8 moles of sulfur dioxide. The conservation of mass, the number of atoms on this side, has to equal the number of atoms on this side. So the number of atoms on the products has to equal the number of atoms on the number of atoms on the reactants has to equal the number of atoms on the products. That's just standard. Okay, so that is a synthesis reaction. We've made sulfur dioxide. It would be released in this very little hot reaction here. Let's look at decomposition. Let's look at a decomposition reaction next. So decomposition, we've got water here, and water is undergoing electrolysis. So write down the words here. Again, your goal in this course is to be given words, a word equation, and convert it into a chemical equation. So what if you were given the following words? Water is broken down, and this could very well be a test question, into hydrogen and oxygen. And this is the process here with electrolysis. And this really works. We send electricity into water, so essentially attach a battery and a wire in and a wire out of the water, and you will, on one of the wires, you'll get oxygen gas forming, and on the other wire, you're going to get hydrogen gas forming. If we put a little test tube over top of each, we'll start to collect those. And notice, and it follows the formula, H2O, for, there's a 2-to-1 ratio of hydrogen to oxygen. You can see it right there. You can actually see the formula for water because we're breaking water apart. So let's make the formula. Now again, it's up here for us, but let's pretend we're just given these words, and now we got to do an equation. Now, of course, we'll just start with a skeleton equation without balancing, but then we will balance this. So let's start with water. Leave a space there so that you can balance it. You know the formula for water. What your goal at this point in the course is to be able to take words and convert them into chemical formulas and chemical equations. Is broken down right there into hydrogen. You know how to write the formula for hydrogen, and oxygen. You know how to write the formula for oxygen. Hydrogen, of course, H2 gas. Oxygen, of course, O2 gas. If we take a look, is it balanced? 2 hydrogens, 2 hydrogens? Oh yeah, no. 2 oxygens, 1 oxygen. Well, let's balance the oxygen. Now we've got 2 oxygens, but we've got 4 hydrogens. Well, let's put a 2 there. 2 times 2 again. There's 4 hydrogens. 2 times 2, 4 hydrogens. 2 times 1, 2 oxygens. 2 oxygens, that's our ratio. 2 moles, which is a very exact amount of water. In fact, it's almost exactly 18 milliliters of water. So 2 moles of water will give 2 moles of hydrogen gas and 1 mole of oxygen gas. And you can actually see that ratio right up here. You can see how this is a 2-to-1 ratio. Interesting. This is a decomposition, opposite of formation, right? We take a compound and break it down into its elements. All right, let's do single replacement reaction. Let's look at that. Here's a single replacement reaction we're looking at. Let's give you the words. Actually, we'll do that in a moment. Ultimately, in a single replacement, a metal is going to replace a metal. So let's see. Oh, we got a good example of that here. Oh, no, we don't. But we do have a good example. Hydrogen will often replace the metal ion. So essentially, you're going to be, you know, this metal here is going to replace the hydrogen. It's going to kick hydrogen gas out. And this here, we're seeing a non-metal replace a non-metal, right? Chlorine gas replaces the oxygen. So it's a single replacement. This one replaces that one. You can see kind of the pattern. But here's the words for this reaction right here. Write this down with me, and also, of course, read it. So magnesium is placed in HCl. You can see what happens. hydrochloric acid. Better give you the words first before giving you the formula. Hydro, it's all one word, I just can't fit it on the line here. Chloric acid. And we see bubbles. Now, if we were just given these words, I know we've got the answer right here, but let's just, you know, this is what's going to happen in the course. You're going to get a test, an assignment. You're just going to be given words to the following and, you know, predict the products, predict what's happening. Because there is a chemical reaction. Something has happened, right? We have evidence. So we know that some reactants went in and we want to predict the products. Those products are definitely going to be related to the reactants, right? So let's write out the reactants. Let's write out magnesium. I'm sure I don't need to say it. You absolutely have to have your periodic table always in front of you, be referring to it. I would suggest also pausing these videos often just so you can check with your periodic table as I teach. Okay, so magnesium, it's a metal, group 2, right? Solid, placed in hydrochloric acid. We know that's HCl. You got to know that. Make sure that's on your periodic table. Aqueous. Pure HCl would be a gas, would be super dangerous. So it's always going to be dissolved in water. And this is in fact a solution of hydrochloric acid right here. And this really is what magnesium looks like. So what is going on here? Well, we suspect something's going on. This magnesium, the hydrogen can act like a metal. So basically the magnesium is going to kick out the hydrogen gas. Yeah, we can see it right there. We can see hydrogen gas forming. So let's write the formula for magnesium chloride. Let's do some rough work over here off to the side. We know the charge on magnesium. Check it on the periodic table right now before I write it. And check the charge for chlorine. I think you know that by now, the charge on chlorine, but just check it on your periodic table. Make it your process. Looking on the periodic table, there's the charge for magnesium. There's the charge for chlorine. So magnesium is +2. Chlorine is -1. For every 1 magnesium, the simplest ratio to balance this off, 1 to 2, right? And again, remember what this means. The magnesium has 2 electrons to give away. 1 chlorine will not be enough. We'll need 2 of them. Or just do it mathematically. How do we make this 0? I need 2 -1s. 2 -1s put together with a +2 is going to be nice and 0. So this formula is going to properly be MgCl2, right? Aqueous, we can actually see that. It's not sort of some solid forming. And also, what's this stuff? These are bubbles. It's a gas. Well, what did we kick out? Write that gas right there. H2, hydrogen gas. Okay, is it balanced? 2 chlorines, 1 chlorine. Let's put a 2 there. Oh, we had 2 hydrogens as well, I think. We've just balanced it. Because 1 magnesium, 2 hydrogens, 2 hydrogens, 2 chlorines, 2 chlorines. It's balanced. 1 mole, which is a specific mass of magnesium. So it's like a cup, right? A cup is a specific amount, or a dozen. It's a better example would be a dozen. A dozen eggs is a specific number. A mole is actually a specific number of magnesium atoms, which has a specific mass. So 1 mole of magnesium atoms, 2 moles of the hydrochloric acid molecule will give 1 mole of magnesium chloride and 1 mole of hydrogen gas. Okay, so that is a single replacement reaction. Next, we're going to look at double replacement. Okay, so it's just going to be a little bigger reaction because this is a single replacement. Let's look at double replacement. We've got an example here of a double replacement, but ultimately you got compound AB, okay, so this one right here, so lead nitrate, and combined with compound CD, okay, sodium iodide. Well, now the A is going to kick out the A is going to kick out the C. I had to look at it for a second there. The A is going to kick out the C, so it's going to be AD, and therefore the other one is going to be BC, right? Because basically the A and the C replace each other. But you can see that. Look at it here. Look at the Lead kicks out the sodium, becomes lead, iodide, and we can see it forms a solid, forms a precipitate, evidence of reaction right here. And meanwhile, the sodium has replaced the lead. You got lead nitrate. Anything in nitrate is soluble. Again, make sure you got your table of common polyatomic ions. You're looking at that right now because you can find nitrate. You can find, we can find the rest of these on the periodic table. Let's write the words for this. Write this with me, because you could be given these words and then you have to write the equation or balance it at least. So aqueous means it's dissolved in water. It's a solution. Aqueous lead nitrate, most common form of lead, because you're looking at lead. Remember, it's multivalent. If we look at it, I'm just going to take a look at my periodic table. Make sure you find lead. Yeah, it's number 82. This would be lead 2, but we don't have to say it's the most common form of lead. So lead nitrate is poured, and obviously poured gently, and I gotta make my marker work here. It's poured into aqueous, so in other words, a solution, sodium iodide. Creating a precipitate. So a solid has formed. You put two liquids together, a solid is formed. So definitely that's evidence of a chemical reaction. A precipitate of lead iodide and aqueous sodium nitrate. Let's take those words. Now we've got the equation right here, but it doesn't hurt to take those words and realize how you convert them into this formula up here. You might want to press pause, use your periodic table, check the charge on lead, the most common charge, right? So lead 2, and charge on nitrate. Make sure that formula is correct, because maybe there's an error here. Sodium iodide, same thing. Make sure that's correct. Make sure this formula is correct. Make sure these formulas are correct, but you press pause, you probably come back in, leave a space here. Lead nitrate, PbNO3, and we need 2 of those to balance off the lead's charge. And let's combine that with sodium iodide. Sodium's positive 1, iodide is negative 1, so it's just NaI, aqueous, AQ, so it's dissolved in solution. There's our arrow, and it's going to be double replacement. So the lead is going to kick out the, or it's going to replace, not kick it out really, it's going to replace the sodium, and the sodium is going to replace the lead. So they're just going to swap partners. It's like a dance hall here. So PbI2, that formula makes sense, right? Because lead was +2, iodide is -1. You need 2 of those. This does form a solid. Check your solubility table. See if this is correct when we're in adding lead to an iodine atom. Iodine ion, I should say. And finally, NaNO3, sodium nitrate, aqueous, anything with nitrate if you look at your formula, at your solubility table. Now, is this balanced? No. We got 2 nitrates here, only 1 there, so let's put a 2 there. But now we got 2 sodiums, so let's put a 2 here. Ooh, excellent. That just balanced the iodine. Okay, so 2 sodiums, 2 sodiums, 2 iodines, 2 iodines. Okay, 1 lead, 1 lead. 2 nitrates, 2 nitrates. So 1 mole of lead nitrate combined with 1 mole of sodium iodide is going to produce 1 mole of lead iodide precipitate and 2 moles of sodium nitrate aqueous. There we go, double replacement. Finally, let's look at hydrocarbon combustion. Let me flip to that slide. With hydrocarbon combustion, it's any hydrocarbon, and hydrocarbons are hydrogen and carbon bonded together with oxygen. There's other combustion reactions that aren't hydrocarbon, but they all involve oxygen. If we just say combustion, we could mean, you know, say even iron. Iron, different metals can actually burn, which is pretty cool. But yeah, so for this reaction, so let's write this down. Hydrocarbon combustion. Big part of the Alberta economy is hydrocarbons, oil and gas, right? So hydrocarbons include oil, gas, coal, diesel fuel. Technically, glucose is a hydrocarbon. It's got some oxygen in it, so it's not quite. Even cellulose, paper, is basically a hydrocarbon. So when you burn glucose, you get CO2 and H2O. When you burn paper, and you have to fully burn it, you get CO2 and H2O. If you burn wood, you get CO2 and H2O. If you burn butane, methane, etc. So it's any hydrocarbon. So something, again, with hydrogen and carbon plus oxygen. What you need to know, and you just need to know this like breath, these reactions always produce CO2 gas, so carbon dioxide, and water vapor, right, because it's so hot, H2O as a gas. And of course, a whole lot of heat, right? These are hot, 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 hot. If we're going to balance these, well, let's look at one right here. You've got it. Methane burns. So the words could literally just be methane, and you need to know methane. You need to make sure that's on your periodic table. Methane burns. In fact, once we balance this reaction, get the whole thing on the back of your periodic table. If we're going to balance this, we're going to balance carbon first. Then, let's just put the word balance here. To balance, carbon first, then the hydrogen. But really, we balance those two together. We make sure they're good and balanced. Then we do oxygen. Leave oxygen for last. Start with carbon, do hydrogen, leave oxygen last. Okay, one carbon. That's already done. Hydrogen is next. Okay, so for hydrogen, only 2. So therefore, we're going to need to put a 2 here. 2 times 2 is 4. I got 4 hydrogens. I got 4 hydrogens. Carbons are balanced. So now let's count up our oxygens. How many oxygens on this side? 2. How many oxygens here? 2 plus 2. Okay, there's 4. All right, so on this side, put a 2. Now I've got 2 times 2. I've got 4 oxygens there. I've got 2 plus another 2, because remember, this means 2 waters, right? 2 of these, HOH. So there's 1 water molecule. There's another. Oh yeah, we've got 2 oxygen atoms right there in total. I've got 2 there. I've got 2 here. So yeah, 4. So this all balances off. 1 mole of methane, 2 moles of oxygen gas are going to release 1 mole of CO2 and 2 moles of water vapor, plus a whole lot of energy. All right, so let's just quickly summarize everything we've just looked at, the 5 major types of reactions. Again, the only one I'm missing, you'll notice, is the words for hydrocarbon combustion. But other than that, we've got our key reactions that we were just looking at here. Formation, so it's just a couple simple elements make a compound. Decomposition, the reverse, and you can see water being broken down into its elements. Single replacement, there's literally silver in this solution right here, so it's dissolved in silver nitrate. But because we put some solid copper in here, the copper replaces, it kicks the silver out, so it takes the place. So the copper is actually being dissolved in this solution, which is kind of cool. And then a coating of silver is forming over the solution. Double replacement down here. This is the one we looked at where we had the lead iodide precipitate out of solution, so you can see that color change. And then yeah, there's the hydrocarbon combustion. And yeah, I just want to double check on that double replacement. So yeah, so this was lead nitrate. So those two solutions, they just look like water. Of course, they're a solution, right? So there's lead nitrate and then sodium iodide. Both of those just clear solutions. Pour them together. Boom! Beautiful color change, precipitate forming. And that's the purpose, really, of understanding these reaction types, so that when you read a reaction, you know what type of reaction it is. But also, if you're given incomplete information, you can predict the products of these. So there's a whole bunch of reading. Well, not a whole bunch. There's about 9 pages, and it's reading and practice. Also, there's practice videos. So basically, you need to be going through the reading, watching the practice videos for balancing, and you want to get a really good handle on writing these types of reactions, balancing them, and getting yourself ready for the lab, which should be about 4 days from now, 4 class days from now. Okay, take care, science.